Hello there, today we'll be doing design linked lists. This is a pretty tough problem. As you can see, the plus minus is pretty bad. I tried to solve this once already, and I got a pretty unfortunate result because the devil lies in the details. I tried to use cross, helper functions to get this done. However, what the problem was with this problem is that when we're looking at the delete at index function and the add to index function, they differ in the sense that when we delete an index node, we can only delete up until the index, which starts from 0. However, when we add, we are able to add to the size of our array, our linked list, and add that to the tail. So that yields us a particular problem where we cannot use a helper function. And yeah, so let's just get started and let's try to understand the problem. So to understand the problem, we have 5 functions that we want to implement. We have the get function. This get function will attempt to get the index of the item, and if the index is invalid, it is over what we assume to be our max index. So if over max index, return -1. So we do need to keep a size of the array of our linked list. So keep size of linked list. Also, with the add at head function, it looks like we're trying to add at the head of the function, and this means that we can add at a particular index. Let's say we add at the 0th index. And the same goes for add at tail. We just have to add at the size of the, let's say, this linked list. So how does that work? Well, we just have to make sure that if you see the size of the linked list, set that to be the tail, that the most the item that we're looking at to add to. Okay. With that, let's check out the last function, add at index. So with the add at index function, so how this is going to be pretty cool is that we can speed up our time. Instead of just going a singly linked list going forward, we can go backwards, and that way we can go from both sides. So the head points to both the points to 1, while the tail points to 3, right? And that way, when we are looking for our item, this speeds up our search by half, because we have just split this whole item in half, and we can start either the head and go forward, or go from the tail and go back. But it is still O of n operation. Okay, now we do the delete at index. So this is very similar to our add at index. The only difference here is that what we can do is we can only delete within our indexes. So we can delete 0, 1, and 2. We cannot put in, if we try to delete 3, what happens is that we have to return and do nothing. Alright, so the values and index are between 0 and 1000, and do not use the linked list library, and at most 2000 calls are performed. Okay, so with that, we know for sure what we're matching. We're going to create a dummy node, and what we're going to do is doubly linked list. So we have list nodes. What else do we have? And we have pointers. Okay, with that, let's get ready to plan. And it looks like we do have to plan at each particular stage. And so let's just put the plan up here because we're running out of room. So the plan is create linked list node to create head and tail pointer, point them to each other. Head points to tail, tail points back to head. Okay. Third, what we're gonna do with head, with next and previous pointer and value. Okay, we're good with that. And let's see what we need to do for our get function. Okay, so for our get function, if index is equal to self.size or greater, return -1, else search from head to mid if index is half of self.size, otherwise search tail to mid. Okay, and we're going to see how that is done. So next we have the add at head, and we already decided to use this function, and the add at tail, we decided to use the self.size function. And now we have the add at index, and what we're gonna do with that is that we will be adding, will not add above our size. However, everything else will be added. So how we're gonna do this is find the previous and next items depending, using the same method from the get function. And next is that what we're going to do now is that we will be looking at the by splitting in half the values and going from head to mid or tail to mid. Okay, with that we are going to find our previous and next items, then add the new node in between. Next, we will remove the item at delete at index. We're gonna make sure if greater than or equal to self dot size, then return otherwise, look for previous and next nodes to point to each other. That way, basically, what happens is we have a head node, we have a, let's say, 1 and a 2. And what that means is that we're looking at like a 2, and we're basically going to point, if this is the previous and this is the next, we're going to point the previous straight to the next and the next back to the previous. All right, so that's what we're going to do. Okay, with the plan, let's get started with implementation. Let's move the plan down. This is going to get pretty messy. So here we go. Okay, so first of all, let's create that class of list nodes. So how we're going to do this, we're going to do a define init, and we're going to create a val equals 0, next equals none, and previous is equal to none. And now self.val is equal to val, self.next is equal to next, self.pre is equal to pre. All right, perfect. And now let's take the next step and create the tail and head pointers and point them to each other, along with the size. So self.size is equal to 0, self.head is equal to list node, and self.tail is equal to list node, self.head.next is equal to self.tail, and self.tail.next of the previous is equal to self.head. And with that, we are done with our init function. Let's get to our let's get to our get function and see how that's done. Okay, so we're indexing from our index and so basically, if index is greater than or equal to self.size, that means we're going to return -1 immediately. Okay, so like we said, we're going to go for a half. So let's say we have our head pointing to our tail pointer, and let's say we have a couple items in here. Let's say we have a 1 and a 3 and a 1, 2, 3. Okay, that way we have something. Looks like what we did forget in the understanding mode. Oh, we did do that already. We do have a case, but we do not have all the edge cases. The edge cases would be like a, yeah, I can't really think of any edge cases. I mean, we're just, at this point, we'll just throw in whatever is possible and make sure it works, because it is, we have multiple functions, but the edge case happens at each particular function, I think. So the edge case is anything that is greater than or equal to the size. So basically everything has to be from 0 index to the top. Another thing is that if the index is less than 0, so we have to deal with that. Okay, so anyways, so let's say we're trying to get the index. We have 0, 1, and 2. That's how we index these items. So if we are looking for index 0 and we start at current, let's say current is equal to head, what our item is going to be 0 plus 1. So that means that this is our first item. So we do have to move current to this particular point here. So if index is less than or equal to self.size, divide by 2, then current is equal to self.head, and for in range index plus 1, current is equal to current dot next. One thing to think about is that we could set current to head dot next and start it at a 0 index, and that way we can start it here. Okay. Else, if we make a mistake, we'll have to come back and fix it later, but we'll just take our chances here. So self.tail.pre. So we start at our index. So we have 0, 1, 2, 2 index, and 1. Well, 2 is going to be greater than our index, and so what's going to happen is for underscore in range of self.size, our size is now 3 minus the index that we have asked for. So let's say we're looking for index 0, right? Index 2. That means we're gonna move one item back. So current is equal to current previous. If we don't want to move one item back, we can do a +1 here, and that way we do self.size 3 minus 2 is 1. 1. Yeah, that doesn't make sense. Minus 1. But so 3 minus 2 minus 1 is 0, so we stay here. But I think, yeah, let's just do that instead. So the 3 minus 2, that's this. We start here and we minus the 2, and we get 1, so we go down to 3, and we're going to return current.val. Okay, with that we are complete with this process, and let's get to the next function. So the next function is we're just going to add at index at 0 and the val. That way we speed things up by quite a bit, because we don't have to write repeat code, and the more code you write, the more likely you're going to make a mistake. So we just don't want to deal with that, right? Okay, so here we are. Let's take a look at this function. And so if index is greater than self.size, then or index is less than 0, let's return, because we will not be adding that. It will be an index out of bounds. If index is less than or equal to self.size divided by 2, then our prev is equal to self.head. So this is our previous item, and we're going to look for our index. And so basically, if our first item, we're trying to skip the first item, then that means what we need to do is look at the succeeding item. So we're trying to add an item between here and here. So this is going to be our next item. All right. So basically, if it is like if we continue want to move forward, then we'll always be, our first item is 0. If it's 0, then we don't move, then that's perfect. If it is 1, then we move one item forward, and then we use our we're gonna place it in front of our first item. All right. So previous is before the first item. This is going to be our first item. Okay, so for in range of index and prev is equal to prev.next, and with that, next is equal to previous.next. Otherwise, we're going to move from the opposite direction. So our next is equal to self.tail. So instead of, we start here and we're going to move backwards instead. So for in range self.size minus index. So let's say we're looking for 3 minus 2. So we're going to move, if the succeeding self.size is 3 and we're looking for index of 2, that means that's going to be a 1. That means the previous item, well, should be here. Whoa. So if it's here, does that mean we're inserting here? Right. So what happened was, so self.size can be inserted as an item. So we do have a 3 here. So that means nothing will change. And so by sticking it here at the 3, we can just say next equals next.prev. And while that's happening, previous is equal to next.prev. With that, we have found the previous and next for the base cases of the head and the tail. And with that, we can create the new node now. So new node is equal to list node at val, and new node dot previous is equal to previous, new node dot next is equal to next, and previous dot next is equal to new node, and next dot previous is equal to new node. And with that, self dot size plus equals 1. As you can see, this is a really long problem. Okay, now we do the same thing at our deletes, but the only difference is that we cannot go forward if it is greater than or equal to. We just return. There's nothing to return. Okay, we just don't do anything. Okay, same process, but this time around, what we're looking for is to delete an item. And this means that we will need to look for the item to delete. And we're going to look from our head down to our end. So if we start at the head and what we're trying to delete is the 1, right? Then we're not going to move anywhere, and we're going to push this to be not next.next. This is the next item here. And that way we can delete the 1. For the tail side, if we put the next at the tail, right? And we move this item, if we put this at the end, right, the tail, and we don't move it at all, right? So we're going to be able to remove this item, the tail item, by not moving the next to next.previous, but just setting it at where it is. And while that happens, we can move it back if need be, right? And so that we can create our index greater than or equal to self.size divided by 2. Our previous is equal to self.head. And for in range index, the index starting from 0, right? Because we are here, And so basically previous equals previous dot next. And what happens here is next is equal to previous dot next, as you can see here. And otherwise, else, well, next is equal to self dot tail. For in the range, well, what we're going to do is self dot size minus index. So basically, if we have a maximum index of 2, and we have a 3, so that's going to give us a 1 range, and that's going to give us a difference. So we do have to have a negative 1 here to perform this operation. So next is equal to next dot previous. With that, we can get our previous to be equal to next dot previous, as you can see here. And what's going to happen next is pretty simple. So previous dot next is equal to next, and next dot previous is equal to previous. So basically, next dot previous will now point to let's say this item will point to previous, and previous dot next will point to this item here. So this pointing does not occur for 3 anymore, and basically this is gone. So 1 will point to a tail immediately. Okay, so with that, we are done here, and we just need to subtract the self.size. And with that, I think we have done the review as well as the evaluation as we've done earlier. This is pretty long code. We can't fit all this into one screen. So yeah. Okay. Well, with that, let's run the code. And let's submit. As you can see, there are wrong answers, as I said when I tried earlier. And this is pretty good. With that, I believe that this is very good. Let's run a. Why don't we run the review? Why don't we run the review? The full review. We have some time. Let's do it. So here we go. So first of all, let's create this item. So we have a head pointing to a tail. First things first, we're going to add to head. So we're going to take a look at, I'm going to add 1 to head. Okay, so add to head. In this function, we'll look at 0. And if it's not within this, so it is 0. So previous is equal to head. So we're going to have to move this around because of how long this function is, right? So it looks like previous is going to be here at the head, and previous.next is not going to happen because 0, and next is equal to previous.next. Next is here. And so what happens now is that we create a new node between previous and next. So head is now going to point to our new node of 1, and tail is going to point to our new node of 1. And okay, so basically previous dot next is, yeah, so new node is going to point to the next one, and new node is going to point to previous one. And that way we have our linked list, as you can see here. New node previous points that way, new node next points that way. Previous dot next is here. It points that way. Next points back, points at the 1. Okay, now we add at the tail. So let's check that out. So we go totally to add at the index of size tail. So of course this is going to be this particular part. Next is going to be a tail. Next is not going to move, as in next and the tail is the same. And the previous is going to be right here at the 1. And the same operation occurs, and we throw in a brand new item called the 3. course, now we do add an index at 1, so 0 and 1 index. So we're going to add it in right here in the index of 1. And so what happens is between 0 and 1, our size of the divided by 2 is 1. So that means if our index is equal to 1, we're going to move from left to right. So previous is going to be head. And basically, we're going to move up by 1. And next is going to be 3. So what's going to happen is that we're going to insert the item between 1 and 3. And so we're going to have 1, 2, 3 as we suggested. So yeah. Great. As you can see here, this is exactly what one wanted. And now, with that, we're going to get our index at 1. So index at 1 is going to be 0, 1, 2. And with a get index, we are going to get 2. Let's see if that occurs. So right here, let's check it out. If we do a get index of 1, we look in here. If it's in the bounds, it is less than the size. So current is equal to head.next. We'll start here. And basically, we move 0 points and we move 1 time. So current is now here and we return 2. Perfect. With that, let's do delete it at index. So delete at index would be at 1. So we'll delete the 2. And so we're going to show that off as well. Okay, so we're going to delete at 1. This is 0, 1, and 2. And we're going to use this portion of the index. And we're going to look at previous. Previous is going to be head. And we're going to move it forward by index, which is 1. And previous.next.next is equal to this item here. And now we're going to skip over this middle item by previous.next to pointing to next. So basically, no longer point here. We're pointing over there. And this no longer points back this way. And therefore, this is gone. Now, 1 points to 2, points to 3. Okay, very good. And we do a get. We're getting at index 1, which should be 3. And so basically, we take this and go back to the drawing boards, back here. And we do a get. And looking at this, 1 is the size, 2 is the size of this thing. So we're going to start here. Current is equal to head. But next. And what we're going to do is move that index by 1, and we're going to return 3. So this is perfect, as we have shown earlier. That's the review. And space-time complexity is, again, our evaluation is going to be, well, that's the review. And our evaluation is going to be of like O of n for a lot of these. Except for the head and tail, that's going to be O of 1 because immediately we find it. But for everything else, it's O of n. So time is O of n, and space is O of n for maximum creation. Of course, in this case, it's the maximum of 2,000 calls that can be made. So I mean, you could say it's O of 1 in terms of, well, no, this is not. Time can never be O of 1. But space can be O of 1 because we have a maximum O of 2,000 items. So, I mean, 1 item, but it's going to be O of n because we have to iterate through n items to just add the item in. So it's O of n. Okay, with that, I hope you enjoyed the video. This is another very long video. These have been very long videos. Hopefully I can get it all into one screen. I can't do that. Okay, I can't do that. Here's one screen. Here's the other screen. All right. With that, I hope you enjoyed this video. Like and subscribe. Want more videos, check the link in the description below, and I'll see you in the next one.